In this video, we'll see how to find the z-score that corresponds to a percentile on the standard normal curve using the TI-83 and 84. Before we do that, let's review how to find areas under the normal curve from the previous video. Let's say we want the area under the normal curve to the left of z equals 1. So we want all this area here. Our lower bound, we said we're going to use -5. And our upper bound here, we can see is 1. So we're going to go to second, vars, normal CDF, lower bound is -5, upper is 1. Hit enter a few times and enter again, and we get 0.84. So 0.84. Now we're going to introduce a possibly new term, percentile. This z-score of 1 corresponds to the 84th percentile, because percentile by definition is the area to the left. So, to give an example, if you are at the 84th percentile of height, that means 84% of the people have a height lower than your height. So if you're at the 5th percentile, you're on the low end. If you're at the 95th percentile, you're on the high end. So here, we saw that a z-score of 1, using the standard normal curve, corresponds to the 84th percentile. Now, let's say instead of being given the z-score and desiring the percentile, we want to do the inverse problem. We're going to be given the percentile, in this case 84th, and we want to know what is that z-score that corresponds to that percentile. Because of this problem, we already know the answer is going to come out to 1. But how would we do this on the calculator if we didn't already know the answer in advance? So we want to know what is that z-score such that the area to the left of it will be 0.84. In order to do this on the calculator, we can do second vars, which is distribution, and go to inverse norm because it's kind of the inverse problem. So we'll go to second vars. Number 3 is inverse norm, and it wants an area. And the area to be entered is always the area to the left of the unknown z. So the area to the left of the unknown z, when we're interested in the 84th percentile, is 0.84, so we'll enter that here. And then enter a few times, and we get approximately 1, which is what we expected. So inverse norm always returns a z-score. This is not a percent, this is a z-score. This is a z-score of 1. So let's do a similar problem, number 2. Find the z-score that corresponds to the 25th percentile. So a little sketch is really helpful. We want to know what is this z such that 25% of the area is over here. From our sketch, we can see that z has to come out negative. If it doesn't come out negative, we know we made a mistake. So the area to the left of z in this example is 0.25. So second vars we're doing, inverse norm. The area to the left of z is 0.25. And let's see what z-score we get. We get a z-score of negative 0.674. This means that if it's a normal distribution, then to be at the 25th percentile corresponds to being 0.674 standard deviations below average. So we can use inverse norm to find a z-score that corresponds to a percentile. Sometimes we might have a different type of problem we want to do. So for example, here in number 3, we want to find the z-score such that 60% of the area is to the right of that z-score. We can't do inverse norm of 0.6 because the thing that you enter into the calculator has to correspond to the area to the left of the desired z. So if 60% of the area is to the right of this z, then it follows that 40% of the area is to the left of this z. So the thing that we have to enter, the area to the left of z in this case, is 0.4. So we will go to second vars, inverse norm, 0.4, and we get a z-score of negative 0.253. So remember, inverse norm always gives a z-score. And let's do one last problem. In number 4, we want to find the z-score such that 90% of the area is between plus and minus that z. So We know the answer is going to be bigger than 1 because 68% is between plus and minus 1. And we know the answer is going to be less than 2 because 95% is between plus and minus 2. So at least we have some idea of where our answer should be. So what is this z-score such that 90% lies between plus and minus z? In order to use the calculator to find the z-score, we have to give it a percentile. We have to give it the area to the left of the unknown z-score. The area to the left is not 90%. This area is 90%. So we have to add on this area in order to find the area to the left of the z-score. So if 90% is in the middle, we're missing 10%. So by symmetry, 5% is on this side and 5% is on this side. So this z-score has 95% of the area to the left of it. So using the calculator, we have to enter 0.95, not 0.9 in this case. So we'll go to second, vars, inverse norm, and we're entering 0.95. Enter, enter, and we get about 1.645. Good. So if we want to verify that this makes sense and it answers the question that was asked, the z-score such that 90% is between plus and minus it, we could go back and just to show that this works, we could go second vars, normal CDF, enter our lower bound of negative 1.645, upper bound of positive 1.645, and hit enter a few times, and we get the expected 90%. So remember, in the previous video, you entered 2 z-scores to get back an area under the normal curve. And in this video, we entered an area, specifically the area to the left, and we're get back a z-score. That's it for this video. If you liked it, give it a thumbs up and subscribe below.